This is the question you are expected to answer. Similar question. It's just the changes is on the masses. Here, the masses include 30 grams. The 30 grams here is the constant mass, but for your own this year, it is 100 gram mass. Then we have 40, 50, 60, 70, 80. So for this year, it's going to be what? 50, 100. Can you see? This is the constant for this particular year, but your own is going to be 100 grams. Hello guys, I want to quickly run you through the practical. One of the practicals expected in this year's NECO Physics exams. So this one is under equilibrium of forces. If you pay attention to this video, you will be able to learn how to carry out the practicals yourself, and also how to use formula to determine your values and to know if you are even correct or not. These practicals formulas can be used, but I would advise you to carry out the practicals yourself. So you are going to be provided with a knife edge. As you can see, this is what we call knife edge. Then you will be given set of masses 50, 100 grams. Now for 50 you are going to have a single mass, for 100 a single mass. Then for 150 you are going to combine 100 and 50. For 200 you join 100 and 100 together. Then 250, 100 plus 100 plus 50. Then for 300 you have 100 plus 100 plus 100. Then the constant mass for this year's exam is expected to be 100 grams. So meaning you'll be given 4 100 gram masses, up to 4. Then 150 gram mass, so that you can be able to combine this to obtain or to carry out your practicals. Is that clear? Then you might be given a thread or a solid tape or masking tape, anyone, so that you can use them to attach your masses on the meter rule. But first of all, the first procedure is to measure your center of gravity on the meter rule, meaning that you are not meant to attach any of the masses to the meter rule before measuring your center of gravity. Just place your meter rule on the knife edge and keep adjusting until it can stand on its own without falling either to the right or to the left. So let's see it. Let's demonstrate that. As you can see, I placed my meter rule on the knife edge. You can see it's standing on its own. It's not falling to the right nor to the left. Can you see that? Can you see the space? Yes, can you see that? So with these, I can measure my CG. So this is my center of gravity. And this center of gravity is to be maintained throughout the practicals. So let's zoom in to the value. What can you see? The value is 50 centimeter. So you can see it is at the center of the meter rule. So you maintain this value throughout your practical. Make sure that 50 doesn't move away from your knife edge. Then you place your constant mass. You place it. The position might be 10 centimeter. It might be 15. It might be 20. Okay, but the practical I'm going to show you a particular diagram. That one is on 25 centimeter mark. That should be 2012 NECO exams. So please go and check that question properly. Now you are meant to fix your 100 gram mass constant for this year. You are meant to fix it either on the 10 centimeter mark or 20 or 25, depending on how the question comes. So please take note of this, please. Okay, so that you know where to position your constant mass. It will be solid taped and it will be written as M. So, but you should know that it is 100 gram mass. So you can clip it this way, then you hang it on the position as displayed on your diagram during your exams. Okay, then at the other end, you're going to place the first mass. For this year, the first might be 50, then followed by 100, then 150, 200, 250, 300. If they like, they might skip 50 and begin with 100, 150, 200, 250, 300, and 350. They can do that. So please take note of that. All right. So let me try to do this now using 50-gram mass. Remember, my CG is 50, so I'll maintain that 50. Then my mass here is hung at the 10 centimeter mark. All right. Then I'll keep adjusting the 50-gram mass until this is at the state of equilibrium. Remember, the sum of anti-clockwise moment must be equal to clockwise moment. So we keep adjusting until the ruler can stand horizontally without falling down. So can you see that? If you observe, my constant mass is still touching the table. It is not meant to. So I'll keep adjusting. Let's keep adjusting this until that constant mass doesn't touch the table. All right. So let's do that quickly. Let's adjust. We keep adjusting. Please don't remove your hand totally. If you do that, the whole thing can fall down or fall out. So your hand should be very close to it. Now, while adjusting, you observe. So my ruler is at the state of equilibrium. Can you see the space? Let's look at this side. Can you see that it is not touching the table? Can you see that? So once it is dangling this way, don't waste your time. Please, probably there will be external forces. Please turn off your fan to avoid external forces. So here, at 10 centimeter mark, I'm having 90. When my constant mass is at 10 centimeter, the other mass was at 90. So that 90 position is my R. For me to obtain the differences, it will be R minus my center of gravity. So I'll keep changing or replacing my masses until I'm done with my practical. Is that clear? So from the knife edge to your left, everything must remain constant. The only thing that will be changing to your right is your mass and the position of the mass. Take note of that. The mass and the position of the mass. Now, this practical, my constant mass, I used 100 grams and I placed it on 10 centimeter mark. If I'm using the same 100-gram mass at my right hand side, where do you think the state of equilibrium is going to be? It is meant to be around 90 centimeter mark, so that will be equilibrium. So based on this, let's look at it. You can see these are the state of equilibrium when I use 100-gram mass. All right. So if my constant is 50-gram mass, all right, at 10 centimeter, then my 100-gram mass, you can see my CG is still 50. My 100-gram mass is on 71 centimeter mark. Can you see that? Can you see that? So that is how you run your practical, please. If you understand this concept, you can carry out your practical perfectly and you obtain your results wonderfully. Is that clear? If you have any questions, you can drop them in the comments. But after this, you can proceed. I'm going to stop here so that I'm going to show you how you can use your formula to obtain your results. And then I will show you how to draw your graph and how your graph is meant to be. And I will also show you how you can obtain your table, how you can draw your table. Is that clear? Please look at what I just did. I attach 100-gram mass to another 100-gram mass. Can you see the attachment? That is how you do it. If they give you thread, fine. If it's not thread, it might be solo tape. And if it is a solo tape, it might be on the meter rule, not hanging on the meter rule. So I prefer thread because the thread can be at that exact position and you can take your reading. So whichever method you prefer, if you need solo tape, use it. If you want thread, also use your thread. Exactly. So look at it. I've been able to obtain my state of equilibrium. Can you see? This is what you're going to do throughout your practical. You can see it's dangling. Don't wait just take your reading immediately and move. You don't have time. All right? So that is that for this. Let's move to the table now so that I will show you what we have. Now, if you are yet to subscribe, please subscribe to our channel for more tutorials. Now, this is a question you are expected to answer. Similar question. It's just the changes is on the masses. Here, the masses include 30 grams. The 30 grams here is the constant mass, but for your own this year, it is 100 gram mass. Then we have 40, 50, 60, 70, 80. So for this year, it's going to be what? 50, 100. Can you see? This is the constant for this particular year, but your own is going to be 100 grams. Take note of this. So I'm going to extract the most important data from this question. Then for your own this year, it's not going to be 40 or 50 or 60. It's going to be 100, probably 150, then 200, 250, and then 300 if they wish. Or it might be 50, 100, 150, 200, 250. I hope that is clear. Please take note of these. There's no way you find 40, 50 because 10 gram mass or 20 is not being attached in the white paper. So this is the expected practicals for this year. Read and record the point of balance G on the meter rule. Based on what you have seen, my CG is 50, but let's assume it is 51 cm. Please, you are asked to measure it so that it will be used in marking your script. So if it is 51, write 51. Then my PG is equal to D. How are you going to find it? You will now say that your G minus your P will give you your D. So let's write that so that we have this to be G minus P, which is 51 minus 25. From what I did earlier, it's meant to be what? 50 minus 25, which will give you 25 cm. But here, we're having 26 cm. Please take note of this. I'm doing this so that you have an understanding or idea that your CG may vary, which is why you are measuring that. Then our GR is equal to D. So what is our G and what is our R? So it's going to be R minus G, which is equal to D. So the R minus G, our G is 51 based on what I'm doing now. But from the practical earlier, it was 50. So it's going to be R minus 50. Is that clear? Please take note of this. So that D inverse will equal 1 over D. And where are you getting your D from? It is gotten from this. Can you see it? R minus 51 will give you your D. And that is what you are meant to find during the practicals. Then your slope. How do you calculate for your slope? Your slope is change in mass over change in what? D inverse. Is that clear? So that you have M2 minus M1 all divided by D inverse 2 minus D inverse 1. This will give you your slope. Is that clear? Then your constant K is equal to S over D. Please, I'm going to tell you something now. Take note of this. Your 100 gram mass is meant to be solitaped and written as M. Are you here? So your K is meant to give you your constant mass. So if the value of the mass is what? 100 grams, your K is expected to be close to that constant value. So if your constant is 100, your K is meant to be very close to 100, either by approximation or by whatever. You can obtain 99 point something or 100 point something so that they can verify if your practical is okay or not. So I'm giving you this clue so that you even know if your answers or your practical is okay or not. So let's draw our table now. Okay, we have our mass in grams. Then what again do we need? We need our D in centimeters. If you like, you don't need to write this in the table. Okay, you can write it somewhere. Then our R in centimeter must be captured, because that's what you're looking for. Then our D in centimeters must be captured. Then D inverse in centimeter inverse must also be captured. Take note of this. This is how your table is expected to look like. Now remember, your D in centimeters, if you like, you don't need to include it in the table. Please take note of this. If you are using 2 decimal points or places throughout, use that. If you are using 1, use that. Please take note of all these. They are very important. So we are going to repeat this practical, let's say 5 times. All right, here we are going to use formula to obtain these values. So 50, 100, 150, 200, and 250. Remember, I can get to 300. All right, so for our CG, we are using 51 cm. Please remember it was 50. This is for the sake of teaching. Mass is 100. Is it kilogram or grams? So I leave this to you. Is it meant to be kilogram or grams? Remember what is given to you. So this is meant to be our constant value. So let me tell you that it is meant to be grams. Don't forget that. Now, based on the principle of equilibrium, the sum of anti-clockwise moment is equal to what? Clockwise moment. So let's write it. Anti-clockwise equals to clockwise. Exactly. So based on this diagram, in fact, this is how your diagrams is going to look like. So we're going to have mass multiplied by what? Our distance, or force multiplied by distance. Mass multiplied by distance. Exactly. So what is our mass? Our mass here is constant. So M into our CG or G minus our P is equal to M into R minus G or CG. Okay, so that M into our G minus P is 51 minus 25. But recall it is 50 minus 25. So that our M into R minus 51. Please, that is your CG. Take note of it. Make sure you measure that. Your CG should be the first thing you should find, okay? Because you need it. M into 51 minus 25 equals M into R minus, okay, minus 51, which is your CG, okay? If you are using formula, this is what you are meant to do. M into 26 equals M into R minus 51. Exactly. So this is the formula you are going to use throughout. And our M is 100. So if you substitute, you are going to have what you are seeing. Exactly. So 100 multiplied by 26. What are we going to have? 2600 is equal to M into R minus 51. So this is the formula. If you want to use formula, this is what you are going to use throughout. Your 51 should be your CG. Use it and go. So let's use 50 now. So if you use 50, you're going to have what you are seeing. So that 2600 is equal to 50 R minus 50 multiplied by 51. What are you going to have? You are going to have 2550. So you collect like terms, so that 2600 plus 2550 equals 50R. Divide through by 50 so that your R will equal this. Our final answer is meant to be, let's do that quickly, so that we have 5150 divided by 50 will give us, let me check that, it will give us, answer is going to be 103. 103. Now if you observe, the total length of our meter is 100 and our R is now 103. Is it not greater than the total length? But let's continue. So that R minus G is equal to this. So 103 minus 51 will give you 103 negative 51 will give us 52 centimeters. Now, the problem is if you write 103 on your table is very wrong. The total length of your meter rule is 100. So please, this answer is not meant to exceed 103. Is that clear? It's not meant to exceed 100. Yes, that's a fact. So take note of this. Is that clear? So please, I'm not going to write this 103. Instead, I'm going to write either 99 or 98. But I'm going to write 99. Is that clear? So whichever value they are going to give to you as a position of your constant mass, even if you use formula, it cannot exceed whatever the length of your meter rule is. Of course, it is 100 centimeters. Is that one clear? Please, I had to do this so that you will know that if you now use formula and don't observe some of these things, you end up failing your practicals. Please take note of this. This is a very serious secret I've given to you. So let's proceed now. Let's proceed. You see, these are table. Let's proceed now before we begin to fill this table. Now our D is equal to 51 minus 25, right? Based on this calculation method. So here I'm going to have 26, 26, 26 throughout. And I told you, you don't need to capture this on this table. You can write it somewhere inside your answer booklet, but you must write it. So I'm writing 99, please. Instead of 103, I'll write 99. Okay? Then, let's proceed. I'll pick 1 again. I've used 50 gram mass. Let's use 100 gram mass and substitute into that formula. So that I'll have 2,600 is equal to 100 into R minus 51. Alright? Because that's our CG based on this calculation. So 2,600 is equal to 100R negative 100 multiplied by 51 is 5100. So that 26 plus 51 divided by 100. This, our R, will now equal what? If you divide this, our R will finally give you our answer to be 77 centimeters. 77 centimeters. So I can go ahead to write 77 or I can write 76. Is that clear? If you write the exact values when you use calculator or formula method, it will show that you have used formula and you will fail. So the essence of practical is to ensure that student carry out the experiment himself and is able to achieve some accuracy. So please take note of this. Okay? Even if you are not doing this completely, you can run 2 or 3 practicals yourself. Then the rest, you use your brain to feel that. So I'm going to rush through the rest now because you have understood the concept of using this formula so that we'll rush and fill out the table, then we'll draw our graph quickly. So if you are able to fill up your table this way, what next? Your D is equal to R negative your CG. So that your D is equal to, for the first one, 99 minus 51. So that if you say 99 minus 51, our answer becomes 48. Okay? Everything here is in centimeters. Then our D is equal to 76 minus 51. What are we going to have? You write it. If you want, you can also use decimal places when writing your values. Alright? You can say 48.0, 25.0, and then you proceed that way. We have 17, alright, 0.0, and then what again do we have? 13. If you say 64 minus 51, you have 13. Then 60 minus 51 will give you 9. So D inverse is now 1 over D, which will give you 1 over 48. 1 divided by 48, what are we going to have? If you do that, we have 0.021. So maintain this standard throughout. Is that clear? So the next one will be 0.040. Then 1 divided by 17, 0.059. Okay? Then 1 divided by 13 will give you 0.077. Can you see that? The 1 divided by 9 is 0.110. Take note of that. Alright? Then we're meant to plot M in grams against D inverse. So meaning M will be on the vertical axis and D inverse on the horizontal axis. So let's go to the graph now so that you see how it's going to look like. So let's assume that you're able to carry out your practical perfectly. So you have your vertical axis and horizontal axis, as you can see being displayed. So if that is the case, our vertical axis we have 50, 100, 150, 200, 250, 300, and so on. Okay, and I use what? 2 centimeters to represent 50 units on the vertical axis. On the horizontal axis, I'm going to give you a secret. If you observe our values, they are in decimals. How do you do that? So I'll advise you to forget about the zeros before the real numbers, right? So that you now plot the real numbers. Then later, you attach your zeros before them. Can you see that? I have 0.020. I know that the other one is what? 40. So 0.040, 0.060, 0.080. Then I'll have 0.100. Okay, then I will have 0.110. All right, so I've gotten what I needed. Please, you don't need to work yourself out. Just write the real numbers and attach the number of zeros before them. Okay, when my mass was at 50, I have 0.020. Can you see that? Then when it was at 100, we have 0.040. Then when it was at 150, our value is 0.059. So it's very close to 0.060. So we'll have it here. All right. Then what again do we have? 200 is 0.077. So it's going to be very close to 0.080. So it will be very close. So we'll have this as my 200. Then the last one, which is 250, is going to be 0.11. Then the last one is going to be on 250. Okay, 250 is 0.110. Now I'm going to place it here. But where is it meant to be? It's meant to be on 250. Okay, but if you observe, that one is out of it. So let's draw our line of best fit. Can you see it? We draw it this way. Let me try to adjust it. If I adjust it, you see that how many have entered? Almost 4. But if I take it back to 0, it's going to be 3 or 2. So take note of this. Then this becomes my slope. All right, my change in y over change in x, which is change in m over change in d inverse. I hope you are following. So by substitution, what are we going to have? We're going to have 200 minus 50 all divided by 0.077. All right, 0.077 minus 0. Let's look at it, 0.021. So that this will equal, what are we going to have? 200 minus this, 150, divided by 0.077 minus 0.021. What are we going to have? We'll have 0.056. All right. If you go ahead in dividing this value, then your answer will become, our final answer becomes slope is equal to 2678.6. Are you here? 2678.6. And it has SI unit because it's going to be grams divided by what? Centimeters. That is gram per centimeters. Now our K will now equal S over D. Alright? K is equal to S over D. By substitution, 2679 divided by D is 26. So if you divide this, our K will now equal 103.04. Now, this K, let me give you a secret now, is meant to give you either by approximation the exact value of your M, which was solid-taped, and the mass is 100 grams. So if your K is not giving you 100 grams, then you need to recheck your work. Your K is meant to give you close to, or then your K should be around 100 by approximation. Take note of that, or less than. But the differences should not be greater than 1. Since your constant is 100, your answer can be within 99.5 to 100.4. Take note of this. So, wishing you all the best in your exams.